So let's solve this particular differential equation by using the method of variable separation. First, we will rewrite this differential equation as dy over dx equals to 1 over x plus y whole squared. Now clearly, the term or the expression on the right hand side is a function of ax plus by plus c. So this is of the form dy over dx equals to function of some polynomial ax plus by plus c. So what we'll have to do here, we'll have to assume that x plus y is equals to some variable v, and then differentiate both sides with respect to x. So that will give us 1 plus dy over dx equals to dv over dx. On writing in terms of dy over dx, so we have dv over dx minus 1. So that means our original differential equation can now be rewritten as dv over dx minus 1 equals to 1 over, we have x plus y whole square, so that will be v squared. That gives us dv over dx equals to 1 plus 1 over v squared, which is equals to v squared plus 1 divided by v squared. Separating the differentials, we have dx is equals to v squared divided by v squared plus 1 times dv, and this is now in the separable form. So that means we have successfully reduced the given differential equation, which was earlier not in the separable form, and now we have in the separable form. So we can integrate both sides. The integration of dx is pretty straightforward. So that's x, which will be equals to integration. Now what we'll do in the numerator, we are going to add and subtract 1, so that we have v squared plus 1 minus 1 in the numerator divided by v squared plus 1 in the denominator, and this entire integral can be rewritten as x will be equals to integration 1 minus 1 over v squared plus 1 dv, or simply x is equals to integration of 1 dv, so that will be v minus integration of dv over v squared plus 1. So this is pretty straightforward integral. So from the table of integrals, we have x equals to v minus arctangent of v plus the constant of integration c. Now since we have assumed that x plus y value is equals to v, so instead of v, we replace it with the original value x plus y. So we have the following expression. So x and x will get cancelled from both sides, and that is going to leave us with, so we have tangent inverse of x plus y. So x and x will get cancelled, so that will be equals to y plus c. And if we take the tangent on both sides, then we have x plus y is equals to tangent of y plus c, and this is the final solution to our given differential equation.